Have you ever wondered why it's just so hard to do the same thing perfectly every single time? Whether you're baking a cake, writing code, or managing a team, inconsistency just seems to be, well, everywhere. Today, we're going to dive into the science of controlling those hidden forces. We're going to learn how to conquer that inconsistency, starting with a really simple question. Why do things go wrong in the first place? All right, first up, let's really frame the central problem here. This is the one thing that affects literally every single process you can think of, from a massive global supply chain right down to your morning coffee routine. So, really, why is it so tough? I want you to imagine a barista, okay? They're trying to pull that perfect espresso shot. You've got the grind size, the water temperature, the pressure they use to tamp it down. Hundreds of tiny little factors can change from one shot to the next. And that makes one shot amazing, and the next one just kind of okay. That struggle right there is the heart of what we're talking about today.
And guess what? That struggle actually has a name: variation. This is the official scientific term for all those little differences, those fluctuations. For our little explainer here, I want you to think of variation as the main character of our story, and also the villain. It's the enemy of consistency.
Now, this variation, it's not magic, it's not random. It comes from real, identifiable places. It could be a machine tool that's slowly wearing down, or maybe slight differences in the raw materials you're using. It could even be a change in the room's humidity, or something as simple as an operator getting a little tired at the end of a long shift. Every single system has these inputs, and they all add up. So, we've met our villain, variation. Now let's talk about the mindset we need to actually defeat it. And trust me, it requires a whole new way of looking at the world around you. The solution begins with something called statistical thinking. And hey, don't worry, don't let the name scare you. This is not about becoming a math whiz overnight. It's really just a powerful framework for understanding how things actually work. And it all boils down to three simple, but honestly pretty profound ideas. First, all work, everything we do, happens in a system of connected processes. Second, every single one of those processes has variation. It's just unavoidable. So that brings us to the most important one, number 3. The real key to success isn't about getting rid of variation completely, because you can't. It's about understanding it and then reducing it. And let's just be real for a second. The word statistics, it can make a lot of people nervous, right? This quote just hits the nail on the head. So many of us kind of fear it, probably because it was taught in a way that focused on scary, complex theory instead of how to actually use it. But here's the good news. We are skipping the scary math. We're just focusing on the powerful ideas. Okay, now we're getting to what is, in my opinion, the most important insight in this entire field. And it's this: not all variation is created equal. Variation is split into two really critical types. First, you've got what we call noise. This is the natural, expected background static that exists in any stable process. It's always going to be there. But then you have the signal. This is different. This is a special cause of variation. It's like you're listening to the radio and someone suddenly changes the station. It's a specific event that tells you something fundamental has just changed. So what do these special causes look like in the real world? Well, they're things you can actually point to. A machine suddenly breaking down, a brand new untrained operator making a mistake, or maybe using a bad batch of raw materials. See? These aren't just background noise, they are specific events that can throw the whole process off the rails. And this brings us to our first major goal: achieving process stability. A process is stable when you've hunted down and eliminated all those special causes, all those signals. When all that's left is the natural, random noise, that's when your process becomes predictable. You might not be perfect yet, but hey, at least you're consistent. And that's a huge win. Okay, so that's the theory. It's great to talk about noise and signals, but how in the world do you actually see the difference between them? For that, we're going to need a special kind of tool. And that tool is called a control chart. The easiest way to think about it is like this. It's a simple graph that's constantly running a little test. Its starting assumption, what scientists call the null hypothesis, is that everything is fine, the process is stable, and any little blips you see are just that normal, random noise. Until a special cause hits. And when that happens, a data point on your chart will suddenly jump way outside the predictable limits. It's basically the chart waving a giant red flag, screaming, "Hey, over here, this isn't just noise anymore. Something specific and different just happened."
And when you see that signal, you don't panic. You follow a really clear problem-solving framework. You identify the problem, you get the right people together to figure out what the heck happened, and then, this is the important part, you eliminate that special cause so it can't happen again. It's a systematic way to make your process stronger and more robust over time.
Okay, so you've done it. You eliminated the special causes, your process is stable, you're done, right? Well, not quite. Just being predictable isn't the ultimate goal. The real goal is excellence. And this is the critical next step. A stable process is predictable, which is great, but a capable process is excellent. Think about it. You can have a very stable process that consistently produces bad products. Capability is all about making sure your stable process is centered right on the target and meets what your customers expect with very, very few mistakes. And the absolute gold standard for this, the benchmark for process capability, has a name you've probably heard before: Six Sigma. This represents a level of quality that is so unbelievably high that you're producing fewer than 4 defects for every million opportunities. It's about as close to perfection as you can get. We can actually measure this with a score called CPK. Just think of it as a grade that tells you how well your process is performing inside the goalposts your customer sets. A low score means you're kind of close to the edge, a little bit dangerous. But as you improve, your score gets higher. A CPK of 1.25, that's good, you're capable. 1.33 is highly capable, that's great. But a score of 2.0, yeah, that's world class. That's Six Sigma territory. You're not just hitting the target anymore, you are hitting the bullseye every single time. So as we wrap this up, I want to leave you with a question to chew on. Think about your own work, your hobbies, even your daily routines. What are the invisible variations that are holding you back from being truly consistent? And now that you know the difference between just noise and a real signal, what's the first one you're going to tackle?